Hopefully you enjoyed our first video, which was dedicated to unit operations for the distillation column, control and design. So in this lecture, we are going to discuss introduction to separator design, including its basic principles and its way and methodology to separator design. So for the first part, we'll only start with the basic principles, but in the next part, we'll include one example and also continue with the remaining principles as well. If you are ready, let's get started. So, introduction to separators and the basic necessary dictionary in this lecture. As you know, the separators that we discussed for the distillation column, the normal separators, horizontal, vertical, and doesn't matter. So, they are mainly as part of the bulk separators. So, the bulk separator could be either two-phase or three-phase separator. So normally these two or three-phase separations are used for multi-phase or just intermediary stage separation. So these vessels are achieving the finer separation quality. So if your, let's say the aim is to get some purified material, you definitely need to use the separator. They are referred to by type of service, like scrubbers, polishers, knockout drums, just normal separators, flare knockout drums, and etc. So it could be either like the slug catcher and the partial separators and etc. So that depends only the application. Then what is two-phase separator or three-phase separator? As you can see on these pictures, the two-phase separators only dedicated to separate gas and liquid separation. When it comes to vertical or horizontal, on the horizontal one, your inlet liquid and vapor two-phase mixture is incoming to the separator. It could be either also called like the wellhead fluid. Then it will be separated into outlet water, outlet hydrocarbon, and vapor. Normally, this looks like the three-phase separation. Also in the vertical one, you have the inlet mixture, vapor outlet and liquid outlet. This looks more like the two-phase separation. So in the horizontal one, you will only one outlet in the case of two-phase separation. But if you have the three-phase separation, as you can see on this picture, you have one gas phase and two different liquid phases. So based on their density, water is the has higher density. That's why it will be separated from the left side. From the right side, you have the less dense hydrocarbon. So using this weir, so this is called weir, it will be separated. So if it's clear, let's go to the basic principles. So the gravitation principles. So our main aim is to actually size the gravity separators. So it could be either horizontal or vertical. But as the first part, we'll start only with the basic principles. And for the next parts, we'll discuss mainly the horizontal one, because the horizontal is more interesting and it's more applicable in the industry. But for the vertical one, we'll also one more example in the next part. So if you're interested in to size a separator for your diploma work, for your graduation work, or for your job purposes, I highly recommend to get a license from the MySep, because it gives very detailed analysis of your separator, and this is one of the best tools on the internet, I would say. But on normally the search engines, you can look for the different sizing tools, like an Excel worksheet, you can find it and you can use it. But in general, my separator design for two-phase, three-phase, doesn't matter, vertical or horizontal, it's very useful and it's very close to the real values. So I'll add a video link to here and you can watch it later. So if we want to start with the gravitation principles, the first one is the gas-oil ratio. This is actually one of the best famous and popular terms used in the oil and gas industry to characterize production and processing fluid, the gas-oil ratio. So the gas-oil ratio or gas-to-liquid ratio, you can also hear about this. It's the ratio volume of gas over which comes out of solution to volume of oil or liquid, or condensate, at either atmospheric pressure or at any specific process condition. So before you start your design principle, you need to define your gas-oil ratio, which will help you to understand, do you want to size a horizontal one? Do you want to size a vertical separator? Okay, so the next term is field composition. Let me clear this. Field composition and flow considerations. So in this matter, generally the separator must be designed to perform over the full range of flow rate. Let's say if the inlet flow rate is more than, let's say, 40,000 kilogram per hour, so it could be any values. I just took as an example 40,000. So it means that your separator must be designed for the full separation or the compositions that may be present during the life of facility. It should be very detailed design to perform this separation. So this might include change in the CO2 compositions when I tell the compositions, or H2S normally in the natural gas content, or how you reach the gases in natural gas liquids or production water cut, and etc. So it means that whatever you have in terms of the change in the compositions, your separator must be adequately designed for this. So additionally, your vessel must also be designed for considering the change in production flow. For example, if your separator is designed for the 40,000, but as the lifetime change, let's say that your reservoir depletion happens or gas breakthrough happens, it means that your pressure will decrease, your flow will decrease, and therefore your separator must be adequately designed for this value as well. So to handle the anticipated conditions, like the change process conditions during the plant lifetime, so you need to select attentively these field compositions and flow considerations. So, and also additionally coming to flow considerations, the flow could be additional, like the coming out from the reservoir, like with the slugs, flow surge, or in the case of compressor recycle mode, it should be also considered in the principles. So the next principle is dispersed droplet size distribution. When I'm telling about the dispersed droplet size, it's actually the primary driver in the separation processes, because the gravitation or gravitational acceleration, this is opposed by frictional forces, and understanding of the likely droplet size of the dispersed phase is important. So for your proper selection, for your sizing of the separator and selection of the internals especially. So the average droplet size and distribution, in general, it's a function of the upstream processing and effect of the inlet piping on the fluid to the separator. So let's say your horizontal separator, it looks like this. So if it comes from like this, or it either comes from like this, or like this one. So in each cases, in these three different cases, your internals will be different. That's why you need to be careful with selection of the let's say the proper design of the piping, inlet piping, because it will definitely affect your dispersed droplet size. So let's continue with the next principle, which is the flow regimes upstream of the separator. So as a mixture of gas, hydrocarbon liquid, and also the water flows to separator. So horizontal, I'll give an example. The mixture can exhibit the various behaviors, like the different flow patterns. What does it mean? So it could be, let's say, based on the elevation change, based on the difference in the velocities, phase densities. So in each case, your relative flow rates will be changing. So that's why the researchers actually have developed some models, empirical models, to predict the flow pattern in the pipe. So as I give an example in the previous one for the dispersed droplet size, let's say if it's the horizontal one and your incoming fluid coming like this, so your flow could be either slug flow, annular flow, wave flow, stratified one, mist, bubble, and etc. So considering these flow regimes, the different flow types, you need to adequately size your separator. And the last and important one for this lesson, this is the gravity settling theory. So gravity settling theory, it's actually the main fundamental reason for the gravitation separation. So in general, I have added the summary of the equations. So on the next slide, then I'll show you later. So in general, the summary of equations will help you to define the gravity settling mechanisms, and also it gives some general information regarding the droplet size, the different droplet size, how the residence time should be, or how the gravitation force are changing, that had been shown on the next slide. So in general, dispersed droplets will settle out of the continuous phase if the gravitational force acting on the droplet is greater than the sum of drag force of the fluid flow around the droplet and also buoyant forces. So it means that your gravitational will happen. Once again, so dispersed droplet will settle out in the case of your continuous phase droplet size, the main force driving this one, it is greater than, so I had added multiple times greater than, sum of F drag force plus buoyant force FB. In this case, then gravitation will happen. But the thing is that depending on how many times this is greater than this, or it could be it's very close to this one, it's greater than this one, and just a quick reminder that if it's less than, your gravitational will not happen, gravitational separation will not happen. But if it's higher times, so many times greater than this, it means that your gravitation will be very simple and separation will happen easily. But when it comes to the, let's say, the very close to this one, it means that it will take so much time to get some residence of the droplets in the separator, and it means that your residence time will also increase. So the terminal velocity that we are gonna calculate at the end of the story, it will be directly happens due to this balance of this, let's say, the forces. Okay, and let's see the next slide. In this next slide, I have actually cut the some part of this picture, and I have taken it from the GPSA engineering data book. This from the separation chapter, which is the chapter 7. I highly recommend to look through and also review all the principles that have been shown on this book, because it's very useful and it's taken actually from the industry standards. So it's very useful, and I highly recommend to look through for the separator design and also basic principles of the separation. So if you can see it here is that we have 3 different phases, the laws of settling: Newton's law, intermediate law, or Stokes law. Mainly we'll discuss the Stokes law regime in the next lesson, and it will help you to find out this C dash, and this C dash will help you and will be a starting point for your horizontal separation. Okay, so in general, that's all for this lesson, and in the next part we'll continue with the remaining principles, and hopefully we can start the next in the next part the example for sizing the horizontal separator. Here is my 2 different references, and this is the book that I just mentioned to you. So in this GPSA book you can find the other equipment as well, but for the separation one you need to check the chapter 7. Thank you, have a nice day.